Okay, use the given 0 to find the remaining zeros of the function. So if I know one zero is negative 2i, this is a complex 0. I know they occur in conjugate pairs, so if 2i is a 0, if negative 2i is a 0, then positive 2i has to be another 0. So I know I've got x minus negative 2i, x minus 2i. So x plus 2i, x minus 2i. I know those are two of my factors, just given what I've done with the previous problems, right? So let's multiply these and see what happens. Let's multiply them. X squared minus 2ix plus 2ix minus 2i squared. Or maybe I'll do better than that. I'll do better than that. Minus 4i squared. So x squared, negative 2ix plus 2ix is 0, minus 4i squared. We know I squared is negative 1. So x squared plus 4 is what we have here, just from these two zeros. So I know so this is degree 4, right? So if I know x squared plus 4 is the multiplied form of two of my zeros, right? X squared plus 4. Take a look at this. Can I figure out what the next, what another factor would be? Because I know this times this has to give me x to the 4th, so maybe that's x squared there. And I know this times this has to give me negative 100. This times this has to give me negative 100. So maybe that's negative 25. Oh wow, look, x to the 4th. There's the minus 100. Here's minus 25x squared plus 4x squared. That's my negative 21x squared. Okay, perfect. So this factor here gives me these two zeros. And look, I know how to factor that. I know this is x plus 5, x minus 5 all day. It's the difference of two squares. X squared minus 5 squared. I can factor that in my sleep. And I know if I set this equal to 0, right? X squared plus 4 equals 0. X plus 5 equals 0. X minus 5 equals 0. I know the zeros here. I got them already. Negative 2i, positive 2i. I know this 0, if I subtract 5, is negative 5. I know this 0 is positive 5. Negative 5. Yeah, positive 5, sorry. So I use those first two zeros to find all the other ones. I've got all 4 zeros here. Those are my 4 zeros.